Hello everybody, it's Mrs. Avila and I am here to help you develop the unit circle so that you can use it when you're solving for different trig functions. So I'm going to break this up into three parts. We're going to start off with our degrees on the unit circle, working our way around. Then we'll do our radians, and then we'll end up with coordinate points. All right, now just a reminder that when we look at this, we're only looking at certain angle measurements within our unit circle. We're not looking at all possible angle measurements. Now, as we work our way around our unit circle, we're going to start off at 0 degrees. So if I start with 0 degrees right here, and I'm going to start by rotating counterclockwise. Now, this first little chunk that I rotate is going to take me to 30 degrees. In fact, any of these distances, if you look at this kind of larger chunk from 0 to 30, is going to be a distance of 30. Any of these smaller distances that you see how this one's broken up into just a small little chunk, that's going to be 15 degrees. So you'll see after 30 degrees, I add 15 and I have 45. I add another 15 and now I'm at 60. Sure enough, you'll notice that 2 of the 15s add up to 30. And then I have another 30, I'm at 90. Then I'm at 120. Then I'm at 135. 150, 180, and I'm going to continue this pattern. I'm going to add another 30, which is 210, 15, which is 225, another 15, which is 240. I'm down here at 270, 300 plus 15 is 315, and then another 15 is 330. And by the time I make my way all the way around, I'm at 360 degrees. So that's my degrees. Now how to do my radians. Now my radians, you can convert each of these using the ratio of pi and 180, or we can do it kind of in a more visual fashion, and I like to think of it as it's cheesy, but slices of pie, okay? So what I'm going to do to fill in my radians first is I'm going to first suggest that we look at our unit circle in terms of chunks of 30 degrees at a time. So I'm going to look at this as a chunk of 30 degrees. I'm going to look at this next chunk of 30 degrees, this one. I'm just going to kind of use a highlighter to break up the top of our unit circle into slices of 30 degrees at a time. You'll notice that I'm kind of skipping over the 45 degree measurement right now. That's just for the time being. And I can extend this down below eventually. Now I do that because now I can visually see the top portion of my unit circle in terms of 6 slices of pie. So I have 6 slices. I have 1 slice here, a second slice, third slice, fourth slice, fifth slice, and sixth slice. And one thing that we do know at this point is we know that you start at 0, and in radians, by the time you get to 180, you end up at pi. Okay. So now I'm just going to count how many slices out of 6, because 6 slices of pie, 6 slices go into pi, and I'm going to count that. So by the time I look at this first group of 30 degrees, I have 1 slice out of 6. So I could either say 1/6 pi, or you can just say pi over 6. Now by the time I go to the 60 degree marker, I've looked at 2 slices of pie. So I can think of it as 2 slices of pi, or I can think of that as pi over 3. I'm going to continue this and go 1 more slice to get to 90. That's like 3 slices of pi out of 6, which is also 1/2 pi, or pi over 2. Now I'm at my 4th slice of pi. So by the time I have 4 slices out of 6, I'm at 2 pi over 3, or 2/3 pi. And by the time I've gone all the way to 150, I'm at 5 slices of pi out of 6, which is just 5 pi over 6. All right, and then I finally get to this last part, and I'm at 6 slices out of 6, which is where we get just our 1 pi. All right, so that's how I do this top portion to break up my radians. Now, the other thing that you can do is you can use the same idea to continue measuring our radians into the bottom 2 quadrants. So if I continue breaking up this into slices of 30 degrees at a time, By the time I get from 0 and I go all the way around to 210, what I have here is I really have 7 slices of pi, or 7 slices of 30 degrees. So if I go 7 slices of pi out of my original 6, that's where I get my 7 pi over 6. Now down at 240, now I have 8 slices of pi out of 6, but that's the same thing as 4 pi over 3. Now by the time I get down here, I'm at 9 slices out of 6, which is 3 pi over 2. And I'm at now 10 slices of pi out of 6, which is where we get 5 pi over 3. I'm just simplifying the fraction. Now I'm at 11 pi over 6, and that won't simplify, so I'm going to leave it as 11 pi over 6. And by the time I get all the way around, I have 12 slices out of the original 6, which is where I get 2 pi from. Now, you'll notice at this point, I still have skipped over all my 45-degree markers, so I'm going to need to go in and fill those in as well. Let me erase all of my 30-degree lines that I have here. And we're going to go in and just focus on our 45-degree angles now. So in a similar fashion, I'm going to look at my unit circle in groups of 45. So I'm going to make just slices of 45 degrees at a time. And you'll see that if I do that, I have 1, 2, 3, 4 slices that go into pi. So 4 slices go into 180 degrees. So when I go and I look at this 45-degree angle right here, I would say I have 1 slice out of the 4. So that would be like pi over 4. By the time I go 2 slices out of 4, that's the same thing as pi over 2, which we already had. Then I'm going to go 3 slices out of 4. So that's where I'm going to get this 3 pi over 4 here. And then again, by the time I get all the way to pi, I've done 4 slices out of 4, which is where we get just our 1 pi. Now, if I keep going into these lower quadrants, again, I'm looking at it in sections of 45 degrees, not 30 anymore. So at this point, I could say that I have, by the time I get down here to 225, I'd say I have 5 slices out of 4. So 5 pi over 4. And I'm going to jump all the way to 315. I would say that I have 4, 5, 6, 7 slices of pi at that point. So I could do 7 pi out of the original 4. 7 pi over 4. And again, by the time I get all the way around, I would have 8 slices out of 4, which would be back to our original 2 pi. All right, so we can get our radians by counting slices of pi, or you can actually do the conversion that we learned previously back in 9.2. All right, so now that we cleared all that away, I can go ahead and start looking at my coordinate points. Now, a couple of these should be a little bit easier than others, and those are the ones I would specifically say are the coordinates of going directly up, down, left, and right. By definition, the unit circle has a radius of 1, and so this point out here would be going to the right 1 and up and down 0. Likewise, if I go that same distance directly up, I'd be going left, right, 0, and up 1. Here, I'd be going left 1, up, down 0. And then down here, I'd be going left, right, 0, down 1. Okay? It's the other ones that are a little bit trickier. Now, using our right triangle trig with our special right triangles, one thing we found earlier was that we found that you can get your coordinates of the first quadrant. Your x value is root 3 over 2, and our y value is 1/2. That is the same for our 60 degree, but it's flipped. We have our x value of 1/2 and our y value of root 3 over 2. And our 45 degree x and y values are both root 2 over 2. If we know those coordinate values, we can go ahead and find each of the corresponding values in the other quadrants. So if I go directly across to 150, I would say I'm going the same height up, but I'm going the root 3 over 2 distance to the left instead of to the right. And then if I take that point and I go down, directly down to 210, same idea. I can say I went to the left root 3 over 2, and instead of going up 1/2, I went down 1/2. And vice versa down over here to 330. Now I went to the right root 3 over 2, but instead of going up 1/2, I went down 1/2. And as you can see, those 4 sets of coordinates are related. We can do the same thing for our 45 and our 60 degree coordinates. So I'm going to go ahead, my 45 degree marker, I'm going to see what point that corresponds to directly across. And that would be a negative root 2 over 2, but it's still going up a positive root 2 over 2. That's going to correspond down here to 225. Negative root 2 over 2, and another negative root 2 over 2 because I'm going down. And over here, I'm going to the right root 2 over 2, but I'm going down root 2 over 2. All right, and last but not least, our 60 degree reference angle, that corresponds over here to 120. So that would be going like left 1/2, so negative 1/2, but still up root 3 over 2. I'm going to correspond that down to 240. It's going to be going left 1/2 and down root 3 over 2. And last but not least, over here, I'm going to the right 1/2, but I'm going still down root 3 over 2. All right, and that gives us our nice complete unit circle. And there we go. You can look at that, or sure enough, right there. All right, let me know if you have any questions. Hopefully this helps you construct the unit circle. Remember, our big takeaway though is how can you use it appropriately. Please reach out to me or your teacher if you have any questions. Otherwise, have a great day.